You know what's fascinating? Quantum mechanics sounds impossibly complex, but it's really built on just a few core ideas.
I know that feeling. You open the textbook, see all the jargon and formulas, and it's just overwhelming, right?
Here's the thing. Textbooks often give you the formulas, but they forget to explain the simple logic behind them.
So let's fix that. We're going to decode these concepts, starting with the photoelectric effect.
The old way of thinking was all about quantity, but the quantum view, it's really about the quality of the energy.
See, it's not about how many tennis balls you throw. It's all about the energy that each individual ball has. And that's the crucial point. This is the work function. If a light particle's energy is below this threshold, nothing happens.
Now, let's move on to our second big idea. And this is where things get, well, really interesting.
This simple question from Louis de Broglie completely turned physics on its head. And guess what? He was right.
So because your mass is so large, your wavelength is just too tiny to ever notice. It's practically non-existent.
But for a tiny electron, that wave nature is a huge deal, and it's the key to our final concept, why atoms are stable.
According to classical physics, they totally should, but they don't. So what gives? Niels Bohr had the answer. This one simple rule prevents that atomic collapse. It's like electrons are on a staircase. Let me break it down.
These fixed positions are called quantized energy levels. There is no in-between. It's one step or the next.
And get this, the size of that jump down determines the exact color of light we see. This explains spectral lines.
All right, let's bring this all together. Remember that feeling of being totally lost? Let's replace it with your new quantum toolkit.
First up, the photoelectric effect. Just think of that single, strong tennis ball. It's quality, not quantity.
Second, wave-particle duality. An electron's wave is significant, while yours is, well, basically non-existent. It's all about scale.
And finally, Bohr's model. Those fixed energy stairs are exactly why atoms are stable. Simple as that.
So this opens up a huge question, right? If particles can be waves and energy comes in steps, what else out there behaves this way?